Hi, I'm Padma Mallikarjunan. I am an enterprise support manager at AWS, and I'm based out of Austin, Texas. Welcome to AWS Knowledge Center Live, where we share best practices and troubleshooting tips from AWS Support. Joining me today is Victor Babasanmi and Francesco Penta. Can you give us a quick introduction, Francesco and Victor?
Hi there, everyone. My name is Francesco Penta. I'm a principal cloud support engineer in AWS Premium Support, and I'm based in Dublin, Ireland.
Hi, everyone. My name is Victor. I'm a cloud support engineer. I'm at our AWS office in the beautiful city of Cape Town, South Africa.
Thank you for joining us from across time zones to share best practices with us today. Our topic today is scaling work from home capacity for your remote workers with AWS Client VPN. We will introduce the AWS Client VPN and walk through some commonly used architectures to scale connectivity across your on-prem and AWS resources. Before we get into the details, a quick note to our attendees online. Please use the chat window on the right-hand side of your screen to share your thoughts and ask your questions throughout the episode. We look forward to hearing from you. Francesco, can you walk us through what we're going to be talking about today?
Absolutely, and thank you, Padma, and thank you everyone for joining today. So, before we start looking into the AWS Client VPN, I wanted to provide some context into the AWS on the reason why people use the AWS Client VPN services and all the solutions and challenges that our customers face when they try to gain access to remote resources in their company. So they want to give that remote access to companies. So with the current events, there is an increase in people working remotely. I did increase this need for remote access to system, and even though this is not a new challenge, employees might need access to use company resources and applications from basically anywhere. And this can range from operational needs. For example, you are on call, some alarm is going off, you need to log in and check what's happening to resources in your account, and you don't really want to go to the office for doing that. Even a regular requirements. So you could have a traveling salesman that has to check specs or inventory on a private internal website. So in order to do that, companies historically had to maintain infrastructure that allows employees to remotely log in, and this also brings some complex scaling and operational challenges. It's not something that you can do on a whim. You have to plan it out, and normally will require your networking team to interact and set it up and monitor it and basically maintain the entire solution. You also might have unexpected events that can cause spike in the requirements of the VPN that you're using or the access system that you have for your employees. If we don't think about the current situation, the fact that almost everyone is starting working from home, think about a weather event. So snowstorms coming in or anything really, and a lot of people need to work from home because they cannot reach the office. This might suddenly require more and more bandwidth for your users, and this obviously creates a scaling challenge for you. So we get a lot of questions about this. How we can provide remote access, what are the best solutions, how do we scale on peak demand, but more importantly, how we build a solution that's resilient. We want to have something that's robust, that doesn't go down if our customers needs to use it, that doesn't go down and basically puts our workforce not able to work or access those resources. And the making robust and fault tolerant is quite important. It also needs to be easy to use. If you think about the digital transformation that's happening and the shift in working from home, if you have thousands of users in your company, having a solution that allows you to add all those users seamlessly is quite difficult. This is basically the main question. How do you do this at scale? How do you do this safely? And how do you do this properly? If you look a bit about the what people used to do before, even before AWS, you normally would have either on-premise VPN hardware. This might be your firewall, or might be your router that your company uses to access the internet, and people will use that to either through licensing or additional modules to provide that access to the employees. Normally, if then you add the direct connect or site-to-site VPN, bringing the two networks together, the AWS network and your on-premise network, you can use that then to give access to those resources back on the AWS network. Again, this is normally requires licenses, requires setup time. You might not have the right hardware. You might need to buy the hardware, and it creates a few challenges. The other solution, and this is a bit more common with the companies that use AWS natively or do not have a big on-premise presence, maybe a small data center or a small office, is to deploy client VPN infrastructure on Amazon EC2 instances. And again, this is something that's a bit better because you can make it scale by just adding more instances, but it still requires a lot of operational work. You need to monitor it. You need to ensure that that instances get replaced. You need to add your users. So it creates a bit of quite additional moving pieces that you need to ensure these access. And again, the entire premise of this episode is to how we can make it simpler. Another solution, even though less common but very easy to deploy, is the use of Bastion hosts. You just put an instance, you SSH into it, and then from there you can bridge into your own network. Not recommended. It's very hard to build it right. A lot of overhead. You need to think about authentication. You need to think about how users are connecting there, and still you do not have the right level of network access because you're jumping through an intermediate host. It will not be the same as having a network presence on AWS. So based on all this conversation we had with our customers, we decided to build and launch this service. And it was launched at the end of 2018. And it's a fully managed service that provides customer with the ability of securely access both AWS and on-premise resources from any location. And it uses open VPN-based clients, so it supports the same standards. So it requires very little work from the client side. And basically, to recap, secure access to AWS on-premise is highly available and elastic. You don't need to think about what goes into making the solution robust, because you just need to worry about the users that are connecting to it. And it's also extremely easy to grant or remove users and access at scale and manage the traffic inside the AWS network. And we'll go in a bit more details in a bit. Victor will have a demo showing us both the features and how you set up the client VPN. So the one thing I want to talk about is how this works with all our other network solutions. I see there is a question from Malicin that says that can be this used a secure way to send traffic to the internet on insecure networks such as public work from home. And yes, that is something you can do. I'll show in a second how the architecture works, and we can go in a bit more details. So this is the basic setup. You have a client VPN. You bridge that on the deploy that in the subnet in your VPC, and we do recommend to at least have a couple of subnets so that you can have high availability, one per AZ, and that's it. So you can configure routing rules, and again, we'll go in a bit more details. And you have the your client connecting to the client VPN endpoint, and they will get access to the VPC. And this is the simplest thing you can do, and it's quite straightforward to create. But as your organization is growing, as your company is adding more and more solutions and more services, they might have the need to add different VPCs. They might have the need to have a different VPC for different services and expand more and more. What this means is that sometimes you might need to keep up with operational overhead and have additional VPC that you can peer together. So VPC peering is a service that allows you to bridge traffic in between VPCs. VPCs are normally isolated, and you cannot communicate with another unless you bring in a VPC peering. To use VPC peering, you do need to have non-overlapping CIDRs or addressing range in your VPCs. But once you do this, AWS Client VPN works just seamlessly. You get from the client to the peered VPC, just configuring the rules to go in there. The other thing that I want to talk about is about the use of internet gateways. As we mentioned before, we can use the internet gateway as an exit point for your client VPNs. So you can set up a route that goes from the client all the way over the internet using the AWS network and infrastructure. There are certain use cases for this, and you can use, for example, a proxy inside your network, or a firewall, or a software appliance that can monitor customer traffic. The other thing is that as we're growing more and more, you could get with a lot of new VPCs, and peering becomes a non-optimal solution. You have more and more peering relationship to think about, and the VPC peering is non-transitive, meaning that you cannot go from a VPC peered with another to another VPC peered. For this, we introduced the Transit Gateway. So Transit Gateway, think of it as a router in your AWS environment. You can add routing rules to move traffic across different VPCs, and also with VPNs, and we'll look at that in a second. When you add Transit Gateway, again, fully supported by Client VPN, all traffic can go all the way to the Transit Gateway and then follow the routing rules that you have in the Transit Gateway to communicate with the different VPC inside your infrastructure, still allowing you with a lot of ease to communicate with your ever-growing networking infrastructure. But the most interesting thing is when we use this in conjunction with the direct connect or site-to-site VPN connections. Remember at the beginning we said we do have some customers using their on-premise VPN hardware to communicate back with AWS, and that presents quite a few scaling challenges, because you might have only one device, might support only so many clients, and then use the direct connect and site-to-site VPN to go back to AWS. You can do the same, just in the opposite way. You can still terminate your client VPNs in here and then leverage the direct connect and the site-to-site VPN connection to go back on premise. So you don't have to think about scaling your VPN infrastructure on the on-premise section. The client VPN will do that for you and will scale organically, and then you can use either dedicated connections such as direct connect or a site-to-site VPN connection to route traffic back on premise, giving your remote workers access to your office network or your own data center, and so on. So before I leave to the question, and Padma, please let us know if there are questions. I wanted to ask a question to Victor here, because we talk a bit about giving access to the sprawling network that you can have on AWS. This, though, can seem a bit insecure, right? We might have a marketing person doesn't really need to access a VPC that has network configuration or runs different services that they might not have the right to. So, Victor, can you tell us how can we limit traffic from the clients to our VPN, or will that client just get access to everywhere?
Okay. Thanks, Francesco. So the thing with Client VPN is that when you create your Client VPN, it's going to create automatically network interfaces in your VPC. And so just the same way you control traffic from any network interface in your VPC, you would make use of things like security groups that you associate to those network interfaces. You would also make use of things like the network access lists for controlling traffic between your subnets, and your route table for routing traffic to your different network destinations, right? So you have to save the same capabilities you would use normally for controlling traffic in your network. You would use those and apply them to the network interfaces that Client VPN spins up for you. And if you are trying to move traffic across your transit gateway, for example, the transit gateway has the concept of routing domains. It makes things of route tables to control traffic between the different transit gateway attachments. And so you can control traffic flowing across using those route tables. You can even create a black hole route as well if you want to drop traffic from flowing across the traffic gateway. And yeah, so you have the capability. And later on, we'll talk about how you can use client VPN authorization rules to limit traffic. But the important thing to note here is that you have flexibility as to how you can limit traffic flowing within your AWS environment.
Fantastic. Thanks, Victor.
Great. So real quick, let's quickly look at some of the questions that we have on the window. We have great engagement today. Thank you so much for asking the questions. So hi, Vijay SCSA. Your question is there an interactive chat application whenever I face an issue or have questions about services like S3 or Amazon EC2? You can use the forums, and I'll provide the address also at the end of this discussion, forums.aws.amazon.com, where you can post questions. And there's a lot of information if you go through the forums over there, where you can ask questions, and we will have our AWS engineers, and Francesca, Victor, and I are there as well to answer those questions for you. So let me know if that answers your question. I see another question here from Mellison. Francesco, I believe you addressed this a little bit. Can AWS VPN client be used as a way to secure traffic to the internet on insecure networks such as public Wi-Fi? I know you have in a few slides, you'll be talking about this as well, but is there anything you want to add to it now, Francesco?
Yes, thank you for the question, first of all. I just touched briefly onto this before, but you have to, yes, you can do that, definitely. The connection that you have in between the client VPN and the VPN endpoint is encrypted, so it's secure by definition. And you can instead indeed use the internet gateway, so you can have a route from the client VPN all the way from your VPC to the internet gateway to access the internet natively. Obviously, in that case, you're securing the connection because it's encrypted all the way up to AWS, and from AWS is getting out to the internet again. But you can also, if you want to add additional measures like having a proxy or a packet inspector or a firewall of any sort as a security mechanism, you can do that as well by using that as a target in your routing. So basically, that will be the target that the traffic is sent to, and then that will take care of the rest. But to answer shortly, yes, you can do this, and it's actually one of the things that we do recommend if you are sitting on an insecure network.
Got it. And one more question here before I turn this over to you, Victor. So the question here is the AWS Client VPN similar to Cisco AnyConnect? And as you talk to that, could you also just talk a little bit about the differences between the site-to-site VPN and the client VPN, just to wrap that together for us?
Absolutely. Victor, do you want to take that?
Okay, yes. So with regards to the question about is client VPN similar to Cisco AnyConnect? So Francesco spoke earlier about provisioning on-premises hardware as a way that people would normally set up their remote access VPNs, right? And so the AnyConnect client is something you use for connecting to such hardware. So the client VPN, we have custom. We have our own software application that you can install on your desktop, like your Windows, your macOS devices, and you can connect to the client VPN service, right? So the client VPN is a service that you can use a client VPN desktop client on your PC, your Mac, or an open VPN compatible client, or on any of the different devices to connect to the client VPN service, right? While the AnyConnect is not a service, but it's a client that you can use to connect to your remote hardware. I hope that clarifies things.
Yep, that's great. Thank you. And if you have any follow-up questions on that, Mellison, Baptista, or Vijay SCSA, please let us know. And I'll continue pasting reference links to our discussions here today. So over to you, Victor. Show us the rest of the presentation.
All right, thanks, Padma. So I'm going to talk next about the features of the client VPN service. And the first thing I'm going to start with is talking about the fact that this is a fully managed service, right? And Francesco has spoken about the fact that it is highly available and scalable, right? So it's elastically scales with regard as traffic increases, as you have traffic increasing, as you have the number of connections increasing, it automatically scales to handle that demand. And it's integrated natively with AWS services. So, for example, it's integrated with AWS Directory Services, IEM. I'm going to talk about some of the services later on, but it's natively integrated with them, and all of that is managed by AWS. We've mentioned the fact that it's a secure TLS encrypted connection that you would have from your clients to the VPN endpoints. And so you can have the secure connection from any of your clients. And then with Client VPN, you have the ability to manage the connections that you're making to the client VPN endpoints. And so you can monitor things like the metrics for those endpoints. You have access to logs that you can analyze. You can carry out forensic audits. You can use those logs for troubleshooting to understand what your users are doing. So you have that ability to do all of that with the service. And it's also compatible with your employee devices. So, like I said earlier on, there is the desktop client that you can use with your Windows, your Mac OS devices, but you can also use the service with any open VPN-based clients, right? So you can use it with any open VPN-based client that you have for your iOS devices, for your Android devices, for your Linux devices. It's compatible with your employee devices. And then the client VPN, you can enable split tunneling. So with split tunneling, you can kind of use that to optimize client routing. So let's say, for example, you want your clients to route all their traffic from their PCs, their desktops, their devices to through the client VPN endpoint to the internet everywhere. You don't want them to use the normal internet connection on their device. You can enable you can disable split tunnel, and all traffic will be routed through the client VPN endpoints, right? And then if you choose to enable split tunneling, if for example you're trying to optimize data transfer costs, right? You don't want to incur a lot of data transfer costs going to the internet using the client VPN endpoint through the AWS environment. You can enable split tunnel and have your private traffic flowing through your secure tunnel while the internet traffic uses your standard internet connection on your device. So you can optimize routing with that split tunneling ability. That's something that's available for you to use. Do we have any questions?
Hi, Victor. Thank you. Thank you for addressing the question on the use with Android as well. So, Melissa, hopefully that addresses your questions. I do have a couple of other questions for you, and this is a follow-up from Batiza. Questions regarding the AnyConnect client. The question is, can we create the users list which we are allowed to connect to client VPN, such as the AD users?
Yes, and I'm going to be talking about authentication next, because authentication will sort of address what is being raised there. So let me just quickly talk about this. Right, so there are different ways that you can authenticate with your client VPN endpoints, right? There's certificate-based authentication, Active Directory authentication, and SAML-based federated authentication. So with certificate-based authentication, what happens is that you can, when you're configuring your client VPN endpoints, right? You provide a server certificate that is used that has to be provisioned with the AWS Certificates Manager service, right? And you can import your private certificate to ACM. You can use the ACM private CA feature. You can use any of this when you provision the certificates on the AWS Certificates Manager service. And so when doing this, you would also need to ensure that you're provisioning the client certificate that your clients are going to be making use of. So you would have to provision the client certificate on ACM, and then you would have to share that shared on those certificates on your client devices, such that when they're authenticating against the VPN endpoint, they present their client certificates to the client VPN endpoint, and that way they can authenticate against the client VPN endpoint. Now, to go to the questions that's being raised, right? You can use Active Directory authentication, or you can use SAML-based predicted authentication, and so your users can authenticate against the client VPN endpoint using their credentials, right? So, talking about Active Directory authentication, the first thing is that you have to use the AWS Directory Service for this. And if you have like your managed Microsoft ED on AWS, right, you can use that easily. If you don't have it, you can make use of an ED connector, for example, to connect the directory services to your on-premises Active Directory, for example, right? So all of your user data, your identity store, and all of that is on your Active Directory. And so when you're connecting to the client VPN endpoint and you're sending in the credentials, the client VPN endpoint is going to authenticate those requests against your Active Directory, which would have all your user credentials there. And the final authentication method is SAML-based federated authentication, right? And with this, you can have like an identity provider, for example, Okta. You can have an identity provider that would have your identity stores or would probably integrate with the Active Directory or any other SAML compatible identity store, right? So when you're using like a third-party identity provider, for example, you have to ensure that you establish trust between that identity provider and AWS, right? And so you would have to use the AWS Identity and Access Management Service for that, IEM. So when you use that service, you can establish that trust. And so when you are trying to authenticate using the client VPN endpoints, what would happen is that you will be redirected to your identity provider for you to authenticate. When your identity provider authenticates you, because already your credentials are stored on the identity provider. So once your identity provider authenticates you, right, you can provide the SAML assertion, or rather your device will provide that SAML assertion to the client VPN endpoints. And because of the fact that trust has already been established between AWS and this provider, we can authenticate you to the VPN endpoints. So these are like different ways you can do that. You basically have flexible advanced authentication methods that you can use against the client VPN endpoints. And one thing I'll have to note with regards to this is the fact that multi-factor authentication is something that you can do. It's optional. So you can enable this on your Active Directory or with your identity provider. You can do that if you want to have that additional layer of security. And then you also have the ability to granularly control access using things like security groups and authorization rules. And so Francesco asked me a question about how you can limit client VPN users earlier on. And I spoke about the fact that you can use security groups because the client VPN endpoint creates network interfaces for you in your VPC. And so when we do, for those network interfaces, you can create security groups that would basically control outbound access from your client VPN users to the different networks, right? So you can control where you want your users to access. If you want your users to access one network but not another network, you can do that using security groups. And with authorization rules, the authorization rules basically serves as a sort of firewall, to authorize users on what they can access and what they can't access. So with authorization rules, you can say you want all users to access your network. You can say you want users in this group. So you can, for example, you've created an Active Directory group, for example, or you've created a group on your identity provider, your SAML identity provider, for example. You can say with your authorization rules that users in this group should be able to access this network, but not this network, right? You have that flexibility to do that when you're setting up your client VPN endpoints.
Perfect. So, Victor, I wanted to add something here, and thank you very much for the overview. There's a couple of things. First of all, when we're talking about multi-factor authentication, this is something that's optional, but we will greatly recommend, as with all the authentication, you want to have something that the user knows, which normally will be their password, but something the user has. In this case, will be the multi-factor authentication, especially when you're giving access to your users to the entire network or even a portion of the network. You can never be too safe. You want to take all the security best practices in order to avoid users gain access without you wanting them to have access. And the other good thing about the authorization is around the fact that you can have groups, so like super admins or network engineers or your operations that have access to the whole network, while restricting access to a specific groups, and again integrating with the Active Directory or your identity provider systems. Before we move to the client VPN walkthrough, I just want to see if Padma, is there any other question?
Thank you. We have a follow-up question from Baptista. In short, Victor, this is a follow-up question to you as well. Using the client VPN, can I restrict or limit access to the websites that I'm accessing? And as a follow-up question to that, does the client VPN allow you to specify the set of users and authorize only those users to access? And can we do that without using Active Directory? So really two questions here, controlling access to specific sites and controlling and allowing permissions to specific users without the use of Active Directory.
Perfect, thanks. So I'll take this question. Regarding the restricting the client VPN access to certain websites, this is not something that you can do natively just using client VPN. You'll need a proxy that sits in your VPC account that just limits the website they can access, or a gateway that you can use to limit their access. If you knew the IPs beforehand of the website they want to access, you could limit the route tables just to give access to those routes. I would not recommend this approach though, because in a highly scalable world, IP addresses can change, and it is something that can create more problem in the long run. But again, you will need either a gateway, a managed gateway, or a proxy that will limit connectivity to those websites. And regarding the second question, yes, you can definitely set this up without using Active Directory. You can either use your preferred identity provider, and these you could use identity providers like the Google or Facebook as an identity provider, or you could give certificate access, so basically mutual authentication to those clients. You create the certificates using ACM, and then when you're installing the clients on your end devices, it will provide those certificates, and the certificate will basically what is part of the authentication and will allow the user in, and nobody without that specific certificate will be able to connect. And hopefully that answered your question.
Yeah, hopefully that answers your questions, Baptista. Let us know if you have any follow-ups. And to everyone, please post your questions. We have our experts, Francesco and Victor, here, ready to answer questions on AWS VPN client, client VPN. And I'll also keep posting links to references from our documentation as we walk through this. So over to you, Victor and Francesco. Show us what the next step is.
Perfect. So thanks, Padma. And yeah, please keep asking questions. So Victor is now going to show us a bit how this works. So I have a little walkthrough on the demo. So Victor, back to you. Okay,
thanks, Francesco. So let's look at the service in more detail from the AWS console. So we'll go to the VPC console here and find client VPN endpoints. So for today, we already have a client VPN endpoint we're going to use for testing, but I'm just going to create one so that you can see the flow when creating the endpoints. So you specify any name of your choice. You can give it any name tag, my client VPN, any description, and then give it the CIDR range that your remote users are going to be making use of, right? So they're going to be getting IP addresses from the particular CIDR range that you specify. So make sure you're planning the range you want to use carefully. With regards to the server certificates for the client VPN endpoints, you must always provide a certificate for the server. And so here I already have this created. It has to be provisioned in ACM if you remember correctly. And then for authentication options, you can use mutual authentication, you can use user-based authentication. So we've spoken about mutual authentication, where your clients will also need to have their certificates as well. And so if you're using mutual authentication, you would have to provide a client certificate ERN for the client to make use of. With user-based authentication, you can use either Active Directory or federated authentication, right? And with Active Directory authentication, like I mentioned earlier, you have to use AWS directory services. So this is just an example of a directory ID for something I've set up already in this account. But if you're using federated authentication, then you would have to go to your AWS IEM to create the identity provider that you're going to use to authenticate for your client VPN users. So this is an ARN, an IEM ARN for an identity provider that I've already created, but I'm just going to show you what it looks like on the IEM console. So if you go to IEM, and under IEM, you would go to Identity Providers and create provider. So here you would specify SAML, since that's what is supported for client VPN. Give it the name of your choice, and then put a metadata document that you would have downloaded from your identity provider once you've properly configured that provider, right? So that is what would help you ensure you have trust between AWS and the provider. So you can upload here if you want to. So let's just continue back from the console itself. So you can log details of your client connections if you want to, and this would help you to be able to analyze what your users are doing. Can help you to do forensic audits and things like that. So you need the log group for that, which you will create on CloudWatch logs, and you can optionally create a log stream as well for that if you want to. So I'm going to talk about DNS next, and this falls under the optional parameters that you can configure for client VPN. So you have the option of specifying two DNS servers. One will be primary and the other will be secondary, such that if the primary fails, the secondary DNS server can kick in. So you can use the Amazon provided DNS here, for example, and maybe you have some other DNS server as a backup for the Amazon provided DNS. And that would help you, for example, you have a private hosted zone that is associated to your VPC so that you can resolve records in that private hosted zone. You can also use roughly 3 inbound endpoints, roughly 3 resolver inbound endpoints. You can use DNS servers that you have of your choice, like private DNS servers you have in your environment. You can use public DNS servers. The important thing is that the clients must have connectivity to those DNS servers. And so you have to ensure that routing, security policies, all of that is properly configured so that your clients can connect to those DNS servers so that you don't have resolution failures. So I put into DNS servers there. The next thing is transport protocol, TCP or UDP. UDP would usually provide better performance, right? But the thing is that some ISPs may block UDP, and TCP would most likely not be blocked. So you may want to use TCP. It's up to you. And then split tunneling, I've spoken about that already. You can enable or disable split tunneling to optimize client routing. It can help you to save on data transfer costs if you enable it, for example. I've spoken about that already. And so this is where you would enable that option if you want that. Now, after enabling split tunneling, you can specify the VPC that your client VPN endpoint is going to make use of, and then the security group that will be associated to your client VPN endpoints. So you saw that it selected defaults, the default VPC security group, but you can create a security group for the client VPN endpoints and ensure that it has the outbound rules of the security group, has access to the required destinations, so that you can be able to establish connectivity. So after that, then the next thing is the VPN ports. The default SSL port 443, you can use that, or you can use the standard Open VPN port, which is 1194, right? So you can use any of this. Make sure that those ports are open and that your internet provider isn't blocking those ports. So after you've created the client VPN endpoint, then you want to associate it to the target network, right? So you associate it to your VPC, and then you can choose any subnet in that VPC, right? So some rules here, you can only associate one subnet per availability zone. So just be aware of that. And also, we recommend that you associate the VPN endpoint with at least 2 subnets for high availability. So just be aware of that. Just be aware of that as well. It takes some time for you to associate. So let's just move on to the VPN endpoint that I had created earlier on, right? So as you can see, for the endpoint that I created earlier on, it's already associated to 2 subnets. There's a security group that we can use for it, and this is where authorization comes into play. This is very important. As you can see, I have authorization rules here where I'm allowing access from a group called procurement, right, to access certain networks. Now you can go and authorize new users. So you just have to put in the destination network, and then do you want to allow access to all users, or do you want to allow access to users in a specific access group? Now, if you're using Active Directory, for example, you would want to put the security identifier, SID, which identifies the Active Directory group. Or if you're using SAML, then you can use the group name there. So you have the ability to be able to say you want users in a specific group to access a specific network with authorization rules. So as you can see, it's very easy to set this up, right? It's very easy to set this up. And if you want to revoke access, it's very easy. Just select and revoke ingress, and all the users in that group will automatically lose access to the particular destination network. So it's really, really easy to set up with regards to authorization rules. And then finally, route tables, right? When you associate your VPN endpoints to a VPC, by default, the VPC CIDR would be in the route table, right? And that would be sent to your client VPN users. So when your client VPN users authenticate against the VPN endpoints, they will receive those routes in their local route table. Yeah, you can come and say you want to create more routes. Let's say, for example, you want your VPN users to access the internet, you want them to access peer VPCs, your on-prem network, your site-to-site VPN network, and stuff like that, right? You can create routes, put the route destination for those routes, your VPC subnet ID that is associated to the client VPN endpoint. So you can easily set that up, and so you can have your users accessing different networks, not just the VPC in question. So I'm just going to test this out now. So for me to do this, I will have to download the client configuration for the client VPN endpoint, right? So here you can go, you download the client VPN endpoint configuration. You can customize it properly. So you can go and edit the configurations for your client VPN endpoints. But in this case, I'm just going to use the same one because I don't have to edit this configuration. So when you're using this configuration, you will have to go and create a profile for your VPN client. So you can go add profile, select the configuration file that you've downloaded, and then add it to your VPN client, right? So this is add profile. So we're just going to go done and then click on connect. And now since I'm using SAML authentication for this, right, what is going to happen is that it's going to redirect the VPN client here to the identity provider. Now I don't have to enter any username or password because I had already, for this demo, I'd already logged in using my credentials in the browser. And so this is like the power of single sign-on authentication at work, right? So you don't have to put in your credentials multiple times if you have that properly set up with SAML. But you can see right now it's connected. And so I should have connectivity to the VPC in question, right? So just to test this out, let's go to EC2. So we'll go to check for an instance in our environment just shortly. So running instances, and so let's get the private IP for the instance. And so we'll just test connectivity quickly with a simple ping. And as you can see, as you will see, exactly, yeah. So you can see that we have connectivity. And so this is, as you can see, it's really easy to set up. There isn't so much configuration involved to get this working. And so if you properly set this up, your users can automatically authenticate against this client VPN endpoint, and you can gain access to your AWS environments. And if you have site-to-site VPN, if you have direct connects, they can get to your on-prem environment, and as well as the internet if you want them to. So I'll just hand over to Francesco and Padma.
Thank you, Victor. That's been great. So Padma, before we move to the next section, are there any questions from the audience?
Yes, thank you, Francesco, and thanks for the great demo, Victor. We do have a couple of questions over here. So the first question I'm seeing here is from Steve D. Thank you for your question. The question is, after we connect using the AWS Client VPN, is there and before you allow the flow of traffic, is there a way to check for information such as software, OS patch level, and so on?
So first of all, great question. Unfortunately, this is not something that's supported natively into this service. You could technically build something depending on what are you using, both for compliance and for verifying that the version that your clients are running in terms of operating system and patching level are accurate, but you'll have to build this out. One of the ways that AWS Client VPN, as with every other service, offers a full set of API, including an API for terminating connection or for adding or removing routes or access to specific groups. And again, you could, depending on what this client has, verify that with your system that he has the right level of compliance, and then terminate the access if he does not have it. It is a solution you will have to build on, using the APIs and the moving pieces, but it's not something that it supports natively out of the box.
Yeah, just to add to what Francesco said. So I mean, yeah, that is the case. For EC2 instances, for example, right, you can use the Amazon Inspector service for EC2 instances if you are using maybe Windows OS or Linux OS, right? But like Francesco said, for non-AWS devices, now you can't do posture assessment or security assessments.
Okay, perfect. Thank you for answering that questions. And if there are follow-up questions on that, we'll be available to answer these on the forums as well. Another question from Beto_Noble. Thank you for your question. Does AWS support WebAssembly? I did provide a blog post. It's slightly outside of the discussion topic today, but hopefully that blog post will address how you can run applications that use the WebAssembly framework using AWS services. And you can use the AWS Lambda forums for further follow-up questions, and we'll be happy to take those questions over there. There is another question here as well from Batisa. Thank you for all the interesting questions today. What protocol does the AWS Client VPN use? Can we use a web VPN as well, where you add the credentials into the URL instead of having to download the client VPN software on your device? So really, two-part question: what's the protocol, and can you embed the credentials in the URL? Francesco or Victor?
Yeah, so the protocol that he uses is based on the OpenVPN protocol, which is a protocol that, again, on its own and fully compatible with that, and you can use that both in TCP and UDP mode. Regarding the other question, then this is a feature that the service does not support. It's a great feature request to have a web-based VPN, so we'll bring that back to the team for consideration, and thank you for the question. Okay. So, last thing, we're running a bit short of time, and first of all, thank you very much for all the questions. I just wanted to briefly mention a couple of things. So the first thing is around the monitoring of your AWS Client VPN. This is a managed service, so you don't really need to monitor it for availability or resilience or ensuring that things are working as intended. Again, we do take care of all that from the AWS point of view. But we have several metrics that indicates the number of bytes that are traversing the VPN, the number of connections that you have active, the number of failed authentication that the service is getting. Maybe a user forgot his credentials or is trying to connect and is having trouble. And this is fully integrated with the CloudWatch metrics, and you can build alarms out of those metrics in case people are having trouble. You might want to know, you might want to be proactive with your users and reach out if you see an increased number of authentication failures, or if you see that the traffic is lower than usual on your VPN. Maybe there's an issue somewhere, and you might want to look at it. And same thing is that CloudWatch fully integrates with CloudWatch logs. So for delivery of connection logs, there's a number of elements that will be exposed, including again successful authentication, failed authentication, or connections that are getting terminated, and they can use these as well to monitor and have a better insight in what's happening with your connectivity, and create dashboard out of it, or in general have a better view onto the how the service and how your users are using it. So before we leave with any last question, I wanted to talk about last considerations. The service only supports IPv4, and whenever you are setting it up, you need to select a non-overlapping CIDR range between the subnets you're connecting to, the routes, and the client CIDR that you're addressing. This is to ensure that routing can happen without conflicts from the clients to the AWS network. And you need to use at least CIDR ranges of /22 for the clients, which is around 1,000 hosts, and up to a /12, which about 1 million hosts. And as you can imagine, this allows quite a few clients to be connected. And normally you would want to reserve at least half of that for high availability. It's easy to set up. We saw with Victor how easy it is to set up the service, but you cannot change the CIDR. So it's not a big deal. If you forgot, you can just reset up, but keep in mind there are certain things that needs to be decided. So a little planning goes a long way when when enabling this service. And there's also a limitation around 200 groups for the number of people that you can have for SAML or Active Directory authentication. Last thing, as with every other service, there are quotas, basically how many resources you can spin up in your account before having to request for more. This is to protect the accounts and in general the utilization of those resources, but you can contact support no matter what tier or subscription you have to have those limits increased if you need more than those resources. I will not go through the limits because that might be a bit boring and may also change, so I'll refer you to the link in the slide and that we will paste in the chat to have a look at what might be the initial limits, but there should be plenty to get started. And again, if you need more, just contact support. Last thing, if you need help, the forums are there at any given time. If you want to get additional assistance, there's an extensive troubleshooting section for Client VPN. But you can also always contact premium support and select the subscription plan that most suit your needs, and then get real-time assistance in case of business and enterprise support. And with that said, I'll just ask Padma if there are any last questions, and then we'll wrap it up.
Thank you for sharing all of that with us, Francesco and Victor. Attendees online, today we discussed the AWS Client VPN. We looked at the scenarios, when to use this feature. We looked at how to set it up, configure, and monitor it. We hopefully answered all your questions along the way. So thank you so much, Victor and Francesco, for walking us through these tools. If there were any questions that were not answered today, please post those questions on forums.aws.amazon.com, and we will answer those for you. And you can email us any feedback or questions to kc-live@amazon.com. Thank you for joining us today at Knowledge Center Live. Happy cloud computing.
Thank you very much. Happy cloud computing to
Cheers,
everyone.
everyone.
Bye.
Cheers.